In any chemical reaction, there is a energy change, and energy cannot be created, nor can it be destroyed. It is only converted from one form to another, or transferred from one form to another. That's known as the conservation of energy. Another way of saying that is the total amount of energy in the universe is constant. Energy can't be created nor destroyed. It's merely converted from one form to another. So in any chemical reaction, the energy transferred is equal to the total energy required to break bonds minus the total energy given off to make new bonds. So making and breaking of bonds involves energy changes. If a reaction gives off energy overall or gets hot, we say it is an exothermic reaction. So for example, if I put sodium hydroxide in water, it gives off heat. If a reaction overall gets cold or takes energy from the atmosphere, we say that it is endothermic. And an example is when I put ammonium nitrate into water. We're going to look at some chemical reactions now, and we're going to take a look at things called synthesis reactions and decomposition reactions. In exploring endothermic reactions and exothermic reactions. So let's say I had copper sulfate and I was heating it up in a crucible. The minute I stop heating it up, I'm going to stop breaking up this copper sulfate into its parts. So that is an endothermic reaction. I need to keep adding heat all the time in order to make it happen. An exothermic reaction is one that gives off more energy than it takes in. I might need to add a bit of energy to get it started, but then it will continue on its own. The most common one you know is a fire. It takes a little bit of energy to get a fire to go. I need to put a match to it. But after that, the fire will keep on burning. The same is true when I heat magnesium ribbon. It takes a little while for the Bunsen to get it going, but after that, the reaction will keep on burning. And as you know, it burns with a brilliant white flame. Certain compounds break up when they are heated. An example is calcium carbonate breaks up into calcium oxide and carbon dioxide. We call this a decomposition reaction. I break up the calcium carbonate into two things. If, on the other hand, I were to go the other way around, we would call that a synthesis reaction, where I take two things and I make one thing out of them. Synthesis means make, decomposition means break. So if I heat calcium carbonate, it causes it to decompose into calcium oxide and carbon dioxide. If I add a few drops of water to calcium oxide, I can put those together and make calcium hydroxide. That is a synthesis reaction. Synthesis reactions are when atoms of different elements combine to form a new compound. For example, when I put iron and oxygen together, I get iron oxide, which is rust. I have got two things coming together to make one thing. That is a synthesis reaction. Synthesis and decomposition examples. Oxygen and hydrogen in the presence of a flame make water. This is two things making just one thing. That is a synthesis. However, if I take water and I break it up into oxygen and hydrogen, that is a decomposition. If an electric current is passed through copper chloride, we'll break it up into two things, copper and chlorine. So that is a decomposition again. Writing balanced equations for each of those, if I took oxygen and hydrogen and made them into water, I would need to balance that equation by doing that. The exact reverse, 2H2O, breaks up into O2 plus 2H2. That's the decomposition. Copper, CuCl2, breaks up into Cu metal and chlorine gas. here is a little animation, or rather a schematic diagram. You've got your hydrogen and your oxygen molecules, diatomic, diatomic. That's a mixture where I just put them into one container. Add a little bit of heat and kaboom, we land up with water, where I have broken the bonds between the hydrogens and the oxygens, and I have made new bonds in creating water. Now, if I were to take water and pass an electric current through it, I can break it up into hydrogen and oxygen, decomposition. And if I take copper chloride and I pass an electric current through it, I can make chlorine and copper. So CuCl2, which is a salt, aqueous, it's dissolved in water, can be broken up into copper solid and chlorine, and that is a gas.